My father was an engineer, and his father was an engineer, and his father was an engineer. You get the point. I was never going to have a normal childhood. Most people, when they think of STEM toys, they think of things like Legos or those cute little baking soda volcanoes. I was but 5 or 6 when I received my first STEM toy, and it was a middle school level programmable robot with tiny little metal pieces that I couldn't grab and instructions I could not understand. This is not a picture of that robot. I couldn't find a picture of that robot, but it was a pain to put together. But eventually, I got it to work. I remember that moment vividly, hearing the startup sound for the first time and seeing the motors whir to life before quickly turning off because I put the feet on backwards. But regardless, that was the moment that I remember falling in love with engineering, or at least what I thought was engineering. When I found out about NeoCity, this STEM high school with a dedicated engineering track, I was ecstatic. This was it, I thought. This was my chance to learn all the complex math and science that I needed to become an engineer. I spent weeks poring over my admissions paragraph, got advice from anyone who would make the mistake of listening. And then I got it. I got my acceptance. I had done it. I had gotten into the high school of my dreams. There was nothing that could stop me now, I thought, from becoming the person that I always wanted to be. And then I showed up on the first day. And I found that the reality was quite different from what I thought it was. When we were asked to build a bridge, my mind went to what I had seen and only what I had seen. It didn't even cross my mind that there could be other solutions. I quickly found that the people who succeeded at those types of projects were the people who were unafraid to be different. They were often the weirdos or the nerds. They were the social outcasts, the people that nobody wanted to talk to. Meanwhile, I found myself in a bottleneck of my own preconceptions. My ideas of what engineering had to be prevented me from seeing any other possible solution. One of the first principles of engineering that was instilled in me as a freshman is how counterintuitive this field is. I am now at the end of my 3rd year of engineering, and we have covered, in past tense, all of the math and science that we will cover. And it really wasn't that complicated. Basic multiplication and division, maybe some trig functions if they really hated you, but that was it. But the application was a different story. Now, don't get me wrong, there is plenty of complicated math in engineering, but all the symbols and equations, that's the mathematician's job. Blame them. We do not associate with them. We are solely focused on the actual application of these smaller, more fundamental parts. More than that, the biggest lesson that engineering taught me was how to take the perspectives and limitations that the world gives you and tilt your head just enough to gain a new perspective, to take the bounds that the world gives you and use them as a jumping off point instead of the outer limit of what you can accomplish. And my hope is that today you'll see engineering for the rebellious teenager of an applied science it really is. See how thinking like an engineer has applications in our own lives just as much as it does in engineering. So what does it even mean to think like an engineer? What is this engineering process? Well, there's a diagram here. We start with the understand step. We can't even begin to think about a solution if we can't define our problem, what a solution even means. And then once we have a good idea, we move on to the ideate stage, which is basically a fancy word for throwing stuff at a wall till something sticks. You come up with a lot of ideas, and some of them will not be good. And then you will realize that most of them were not good. But eventually, you'll find an idea that actually has promise, and you move on to the prototype stage. You make some sort of physical way of verifying how your idea actually works, something that you can touch and feel and see that shows how your solution would work in the actual context it's going to be in. And then you validate it. How well does it work? Does it not work? Is it a terrible idea that never should have seen the light of day? Does it actually have promise? And then you move on to the most important step, ideate. You take what works, you keep it. You take what didn't, throw it away, try something else. And you start the whole cycle over again. It is this continuous process of bit by bit getting closer and closer to a solution that is the heart of engineering. It is what leads to all of the feats of humanity that people think of when they think of engineering. The Pyramids of Giza, the Burj Khalifa, the ISS, they were all incremental accomplishments. Progress is made in steps, not leaps. There's this idea in behavioral psychology known as behavioral momentum theory. Basically what it says is the more you reinforce a behavior, the more you give it momentum. You make it more difficult to change that behavior later on down the line. This is typically used in the context of bad or disruptive behaviors, but a mindset, a way of looking at the world, is just as much a behavior that can be influenced and, with difficulty, changed. There is a Johns Hopkins paper titled Resistance to Change, a Social Psychological Perspective. In it, it details findings that show humans are more resistant to change when it is tied to a deeply held value system. Now, there are tons of candidates for what a deeply held value system is: religion, politics, and yes, those do count, but then there are the subtler value systems. Our school system acts in every meaningful way like a value system, the way it teaches us what to think and why to think it, and don't you dare question it. And this worked out great in the 1800s when all we wanted were mindless worker drones for factories. But problems arise when you try to take those rigid structures and enact real, meaningful human change with them, because it just doesn't work. How many of us have had a New Year's resolution or knew someone who did? Now, how many of us have actually kept them? Well, we're not alone. According to Columbia University, over 70% of people who start a New Year's resolution fail within just the first month. Resolutions, while neat in concept, don't work for much the same reason our school system really doesn't. It tries to have these incredibly rigid structures of success or failure, and you either succeed at this one super specific thing or you fail, which is far more likely just given how many other outcomes there are. Engineering offers a solution where the world tells you exactly who you are, what you can do, and what you can accomplish from day one. Engineering says, what if we broke those structures? What if we allowed ourselves the space to be curious and question our assumptions? I think SpaceX's philosophy with this is a really good example. They are doing something incredibly ambitious. From day one, they've been incredibly ambitious, revolutionizing reusable rockets. But now they're taking it to the next level. They're in the process of building Starship, a fully reusable rocket, and recently they had their 8th test flight. It was generally considered a success. The first flight went up, did its thing, came back down, no issues. The second stage did kind of explode, but that's a minor thing. It's generally a success. There's an easy lesson to be taken away of try again, and persevere through failure. And yes, those are valid takeaways, but what I really want to emphasize is what SpaceX does next. Analysis. So much analysis. They go through an unfathomable amount of data. Every tiny bit and piece, every fluctuation in temperature, the vibration of even the tiniest screw, because that could be the difference between exploding and actually landing back on Earth. You're dealing with that level of minutia with something as temperamental as rocket science. And they don't do this analysis just for the kicks of it. They do it to inform the ideate stage, so that they can come back not just with different ideas, but with better ideas. Every day, it is engineers who are pushing the limits of what we consider feasible or possible. It is engineers who are designing products that we actually use in our everyday lives that are affordable and improve our quality of life. Someone had to be the first to say, maybe the sun doesn't revolve around the Earth. Someone had to be crazy enough to say, hey, you know that giant rock in the sky, the moon? What if we put people on it? Like, I need to underline how absurd that is at face value. Let's take a giant floating rock millions of miles away that's always moving and put people on it by very carefully blowing stuff up and hoping for the best. But more than that, a lot of people had to be insane enough to make it work, to allow their assumptions to be questioned, to ask different questions if the approach they were using wasn't working. If this type of mindset can work for all the feats of humanity that involve engineering, Why can't it work for us in our own lives? The problem of enacting real, meaningful human change is not unlike an engineering problem. In engineering, we have constraints, things that a design needs to do, like a load capacity for a bridge, or being able to go a certain distance for a car before you have to change the gas. And then we have limitations, things the design cannot do under any circumstances, like exceed a certain budget or have a minimum manufacturing time. And within that is the room in which engineers ideate, iterate, where they create their solutions. We have limitations and restrictions in our own lives for the problems that we are trying to solve. We have goals that we want to accomplish, things that we want to do, and we have limitations. Our goal of self-betterment cannot come at the cost of our livelihoods, of our grades or our jobs. And within that, there is room to iterate. And I think we could all benefit from looking at life a little bit more like an engineer, to venture to understand our problems, really get to the root of why this is happening. Venture to have a ton of crazy ideas, not being afraid to have incredibly stupid ones, because eventually you might find something that works. Being honest when they are incredibly stupid, and being merciful when they actually work. Being willing to analyze, to validate, to go back to the drawing board and take another look at what you're doing. Take what works, keep it. Take what doesn't, throw it away and try something else. That robot that I built as a kid, I never got it to fully work. There was always a leg missing, or a motor wouldn't turn on, or the code was messing up. Something was always wrong. But I was never not having fun, because I was enjoying the process of it. Every day there was something new. Every day there was something to fix, a new problem to solve, and I enjoyed simply going through the process of fixing it. And when the anxiety gets to me, when the voices in my head say that I will never be enough, that nothing I do or say will ever matter, that I will never matter, when the voices around me say that you can't accomplish that because you're too young, your hair's too long, your voice is too high, I cling on to that kid. The kid who simply enjoyed the process of learning, of improving. And I cling on to the field that taught me to be unabashedly different, unapologetically different. The field that taught me to challenge the status quo, to be okay not being normal, to push the boundaries of what we consider impossible in our own lives, like an engineer. Thank you.